All right, this is section 10.5, multiplying and dividing radical expressions. All right, the first example, we want to distribute. So you're going to take the square root of 5 and multiply it by each term. So that'll be 2 square root of 5. You write it this way because they're not like terms, but you can combine that radical. So that would be the square root of 30. You don't have any perfect squares within the square root of 30, so that would be the final answer. All right, so the next one, I would always break down any perfect squares first. So the square root of 12, I'll write that as 4 times 3. 4 is the perfect square within 12. And the square root of 27, I'll write that as 9 times 3. 9 is the perfect square within 12. So then that first square root, I can pull out a 2. The square root of 4 is 2. So now I have 2 square root of 3 minus 3 square root of 3. And now I'll distribute. So 4 times 2 is 8, so that'll be 8 square root of 3 minus 4 times 3 is 12, so that'll be 12 square root of 3. And these are like terms because I have the square root of 3 for each term. 8 minus 12 is negative 4, so the final answer is negative 4 square root of 3. All right, example 2, we want to multiply using FOIL. So we're going to do first, outer, inner, last. And square root of 5 times the square root of 6 is the square root of 30. And then 1 times the square root of 5, that'll be the square root of 5. 3 times the square root of 6, that'll be 3 square root of 6. And then 3 times 1 is 3. We don't have any like terms, so that is the final answer. All right, now we have 7 minus square root of 3 times the quantity square root of 5 plus the square root of 2. And again, we're going to use FOIL. So that'll be 7 square root of 5 plus 7 square root of 2 minus the square root of 15 minus the square root of 6. And again, we don't have any like terms, so that is the final answer. All right, before I do part C, recall the difference of squares. A plus B times A minus B is equal to A squared minus B squared. All right, so as that applies to part C, we have the square root of 10 plus the square root of 3 times the quantity square root of 10 minus the square root of 3. And you can still use FOIL on this, but just know that since this is a difference of squares, you're going to have some terms to cancel out. All right, so let's do first, outer, inner, last. And we will get the square root of 100 minus the square root of 30 plus the square root of 30 minus the square root of 9. So this minus square root of 30 plus square root of 30, that's going to cancel out. So I'm left with the square root of 100 minus the square root of 9. The square root of 100 is 10. The square root of 9 is 3. And 10 minus 3 is 7. All right, part D. All right, the square root of 7 minus 3 quantity squared. You could use the square of a binomial for this, but if I if my mind serves me correctly, I think we just wrote it out twice and foiled it in class. So I'm not sure, but I'll do it that way. All right, so we're going to remember the exponent tells you the number of times to multiply the base times itself. So we're going to write it out twice and then FOIL. All right, so the square root of 7 times the square root of 7 is the square root of 49 minus 3 square root of 7 minus 3 square root of 7 plus 9. That's first, outer, inner, last. All right, so these are like terms. And these will also end up being like terms because the square root of 49 is 7. All right, so now I have 7 minus 6 square root of 7 plus 9. And 7 plus 9 is 16. So 16 minus 6 square root of 7 is the final answer. All right, it's part E. 5 minus the cube root of 3 times 5 plus the cube root of 3. Again, we have the difference of, well, it would end up being a difference of squares, you'll see. So let's do first, outer, inner, last. All right, 5 times 5 is 25. Outer would be plus 5 cube root of 3. Inner would be minus 5 cube root of 3. And last would be minus the cube root of 3 quantity squared. All right, so these middle terms will cancel out. So I'm left with 25 minus the cube root of 3 squared is the same as the cube root of 3 squared, and that is 25 minus the cube root of 9. And that's the final answer. All right, and then part F. We have the square root of k minus the square root of y times the square root of k. I'm sorry, this should be plus. Minus the square root of y. And then just FOIL. So first, outer, inner, last would be the square root of k squared minus the square root of ky plus the square root of ky. Notice I wrote it in alphabetical order. Minus the square root of y squared. All right, so the square root of k squared, that's going to come out as k. These middle terms will cancel, and the square root of y squared will come out as y. So the final answer is k minus y. All right, now for rationalizing a denominator. All right, we have 3 over the square root of 7. All right, in order for you to break down a square root, it has to be a perfect square. So if I multiply by the square root of 7, the square root of 7 times the square root of 7 is the square root of 49, which is 7. So I made it a perfect square. But when you rationalize, whatever you multiply the denominator by, you also multiply the numerator by. So when I rationalize, I will always write what I'm rationalizing or what I'm using to rationalize in red, so that way you'll be able to see it. All right, so then that is equal to 3 square root of 7 over the square root of 49, and the square root of 49 is 7. So 3 square root of 7 over 7. Let's try another one. 5 square root of 2 over the square root of 5. All right, so I'm going to make it a perfect square in the denominator by multiplying by another square root of 5, because the square root of 5 times the square root of 5 is the square root of 25, which is 5. All right, so I'm not sure if I said this, but rationalizing a denominator means that you are removing the radical from the denominator. So you'll multiply by whatever you need to in the denominator in order to get rid of that radical. And whatever you multiply in the denominator, you also multiply by in the numerator. All right, so now we have 5 square root of 10 over the square root of 25, and the square root of 25 is 5. Now, the 5's will cancel out, so your final answer is the square root of 10. All right, square root of 12. If there is a perfect square within your square root, you always want to break that down first. So since I have a perfect square within 12, I'm first going to rewrite this as -6 over the square root of 4 times 3. 4 is going to be that perfect square within 12. So -6 over 2 square root of 3. All right, now I can simplify the -6 with the 2. If you want to go ahead and do that, you can. 2 goes into -6, that becomes a -3. So now I have -3 over the square root of 3, and now I'll rationalize by multiplying by the square root of 3. So that will be -3 square root of 3 over the square root of 9, and the square root of 9 is 3. And then that cancels out. So the final answer would be negative square root of 3.